Welcome to Science in 10 Minutes. Today we're diving into the world of motion. In just 10 minutes you'll understand Newton's 3 laws of motion. These laws explain how everything moves. From cars to rockets, Newton's laws are everywhere. Ready to become a motion expert? Let's get started. First, let's meet the genius behind these laws, Isaac Newton. He was a mathematician and physicist. His work changed the way we see the world. Newton's laws of motion are the foundation of classical mechanics. By the end of this episode, you'll be amazed at how much you've learned. Ready? On to Isaac Newton and his contributions. Isaac Newton was born in 1642. He was a curious child and loved to learn. As an adult, he made many discoveries. His work in physics and mathematics was groundbreaking. Newton's most famous work is the Principia Mathematica. In this book, he introduced his 3 laws of motion. These laws changed science forever. Newton's laws explain how objects move. They also explain why objects move the way they do. Before Newton, people had many ideas about motion, but these ideas were not accurate. Newton's laws gave us a clear, correct understanding. His work laid the foundation for modern physics. Now, let's dive into the first law of motion, the law of inertia.
Newton's first law is called the law of inertia. This fundamental principle was first formulated by Sir Isaac Newton, one of the greatest scientists of all time. It states that an object will stay at rest or in motion unless acted on by a force. This means that without any external influence, the state of the object remains unchanged. This means if something is still, it will stay still. For example, a book lying on a table will not move unless someone or something pushes it. If something is moving, it will keep moving. Imagine a car driving down a highway. It will continue to move forward unless the driver applies the brakes. It won't stop unless something makes it stop. This could be friction, a collision, or any other force that acts upon it. Think of a soccer ball on the ground. It remains motionless until an external force acts on it. It won't move by itself. The ball needs a push or a kick to start moving, but if you kick it, it moves. The force from your foot transfers energy to the ball, setting it in motion. Once it's moving, it will keep going. The ball will continue to roll across the field until another force, like friction, slows it down. It won't stop unless friction or another force stops it. This is inertia. The resistance to change in motion is a fundamental property of matter.
Inertia is like a stubborn mule. Just as a mule resists moving or stopping, objects resist changes to their state of motion. It wants to keep doing what it's doing. Whether it's staying still or moving, it resists any change. The law of inertia is everywhere. From the smallest particles to the largest celestial bodies, everything follows this law. It's why you need to push a shopping cart to get it moving. The cart won't start rolling on its own. It's also why the cart keeps rolling after you let go. Once in motion, it continues until another force, like friction or a bump, stops it. Next, we'll see how inertia works in a real-life example. Stay tuned to understand how this fundamental law affects our daily lives.
Imagine you're in a car. The car is moving at a steady speed. Suddenly the driver hits the brakes. What happens? You feel a jolt forward. This is inertia in action. Your body wants to keep moving forward. The car stops, but you don't stop right away. This can be dangerous.
Seatbelts are designed to keep you safe. They hold you back when the car stops suddenly. Without a seatbelt, you could be thrown forward. This could cause injuries. Seatbelts are a perfect example of how understanding inertia can save lives. They counteract the effects of inertia.
Inertia also explains why heavy objects are hard to move. Think of trying to push a heavy box. It doesn't move easily. The box resists your push. This resistance is inertia. Now, let's move on to Newton's second law of motion.
Section 5, Newton's second law, the law of acceleration. Newton's second law of motion is about acceleration. It states that the force acting on an object is equal to its mass times its acceleration. This is written as F equals ma.
In simple terms, it means that heavier objects need more force to move. It also means that the harder you push, the faster an object will move.
Think of a shopping cart. An empty cart is easy to push. It moves quickly with a little force. But a full cart is harder to push. You need to use more force to move it. This is because the mass of the cart is greater. Newton's second law helps us understand this.
Next, let's see a real-life example of the second law.
Section 6. Real-life example of the second law. Pushing a shopping cart. Picture yourself in a supermarket. You're pushing a shopping cart. The cart is empty. You push it with a small force. It moves quickly down the aisle. This is Newton's second law in action. The force you apply and the cart's mass determine its acceleration.
Now imagine the cart is full of groceries. You push with the same force as before, but the cart moves slowly. Why? The cart's mass has increased. According to Newton's second law, more mass means less acceleration for the same force. You need to push harder to get it moving quickly.
This is true for all objects. Heavier objects need more force to accelerate. Lighter objects need less force. Now let's move on to Newton's third law of motion.
Section 7, Newton's third law, the law of action and reaction. Newton's third law is about action and reaction. It states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. When one object exerts a force on another, the second object exerts an equal force back.
Think of jumping off a diving board. When you push down on the board pushes you up. This is action and reaction. The force you apply to the board is matched by the board pushing you back.
Exactly. This law explains many actions we see daily. Another example is walking. When you walk, your feet push back on the ground. The ground pushes your feet forward. This is how you move. Next, let's see a real-life example of the third law through a rocket launch. When the engines fire, they push exhaust gases downward. In response, the rocket is pushed upward with an equal force. This powerful demonstration shows how action and reaction work together to propel the rocket. Understanding this law helps us grasp the fundamentals of motion and force. From simple daily activities to complex engineering feats, Newton's third law is always at play. It's a fundamental principle that governs how we interact with the world around us.
Section 8. Real-life example of the third law, rocket launch. Imagine watching a rocket launch. The anticipation builds as the countdown begins, and everyone holds their breath. The engines fire, and the rocket starts to lift off. Flames and smoke billow out as the rocket ascends. What's happening here? Newton's third law of motion is at work. This law states that for every action, there is an equal and opposite reaction. The rocket engines push down on the ground with tremendous force. This force is generated by the combustion of fuel in the rocket's engines. The ground pushes back with equal force. This is the reaction force that propels the rocket upwards. This reaction force lifts the rocket into the sky. The rocket continues to ascend, defying gravity.
The fuel burning in the rocket creates gases. These gases are the result of a chemical reaction inside the engine. These gases are expelled downward at high speed. The expulsion of gases creates a powerful thrust. This is the action force. The force of the gases being expelled downward. The reaction force pushes the rocket upward. This upward force is what allows the rocket to soar into the sky. This is how rockets overcome the pull of gravity. By using the principle of action and reaction, they can reach outer space. They use the principle of action and reaction. This fundamental law of physics is crucial for space exploration.
And this law is not just for rockets. It is a universal principle that applies to many different systems. It applies to all propulsion systems, from the engines in our cars to the jets in airplanes. Cars, boats, and airplanes all use this principle. They all rely on the same basic physics to move. Now, let's see how all these laws are interconnected. Understanding these principles helps us appreciate the complexity and beauty of motion in our world.
Section 9. Interconnection of Newton's laws and their daily impact. Newton's three laws of motion are all connected. They work together to explain how objects move. The first law tells us that objects resist changes in motion. The second law explains how force, mass, and acceleration are related. The third law shows that forces come in pairs. In daily life, these laws are always in action. Whether driving a car, pushing a cart, or jumping, Newton's laws are at play. They help us understand why things happen the way they do. Engineers use these laws to design safer cars, better airplanes, and efficient machines. Understanding these principles helps us create better technology. It also helps us stay safe. Knowing the basics of motion helps us appreciate the world. Finally, let's wrap up and encourage more exploration. Section 10. Conclusion. Encouragement to explore more. Congratulations. You've just learned Newton's 3 laws of motion. These laws explain how everything moves. From everyday activities to advanced technology, Newton's laws are everywhere. Understanding them helps us see the world in a new way. Remember, science is fun and exciting. There's always more to discover. Keep asking questions and exploring.
If you enjoyed this episode, be sure to subscribe to our channel. You'll find many more exciting topics in science. Each episode is a new adventure. Share what you've learned with friends and family. Show them how motion works. Until then, happy learning.